So yesterday we talked about arithmetic sequences, sort of a list of numbers that have a particular pattern. What we're doing today is talking about sums of terms in an arithmetic sequence. And so this will be the first example problem that will work together. The first piece of analysis is looking at the numbers 2, 4, 6, and so on, and seeing that there is that constant difference between the terms. And so the fact that there is that constant difference tells me that this is arithmetic. For this first example, I want to help you try and see where the formula for the sum of terms in an arithmetic sequence comes from. The recognition is that if you look at the first term, 2, and the last term, 100, and add those together, I get 102. If I look at the second term, 4, and the second to last term, 98, those two terms together also add up to 102, and that's the key feature of arithmetic sums like this, that I can pair up terms and they'll have this constant sum. And so conceptually, the sum of these terms is going to be, whatever the first term is plus the last term, and then however many pairs there are, and the number of pairs is going to be the number of terms divided by 2. So here, the sum is going to be the first term 2 plus the last term 100. And then I need to figure out how many terms there are in the sum. And that's what we were dealing with yesterday. And so we're going to have to go back and say, in an arithmetic sequence, a sub n equals a sub 1 plus constant difference times n minus 1. And so for this sequence, the first term is 2. The constant difference is also 2. And then 100 is the nth term. So I'll say 100 equals 2n. And so that 100 is the 50th term. And so that's what I'm going to plug in there to the formula to find the sum. 102 times 50 over 2. And then multiply that out to get 2,550. Okay, just work a second example. Same concept. Find the sum. So let's say I've got 10 plus 13 plus 16 plus 19 up to 115. So the first recognition, 10 plus 3 is 13, plus 3 is 16, plus 3 is 19, so it's arithmetic. So the sum is going to be the first term 10 plus the last term 115 times the number of terms over 2. And so I need to figure out how many terms there are. So I say a sub n equals 10, the first term, plus 3, the constant difference, times n minus 1. So 3n plus 7. I'll take 115, it's the nth term. And so I get here n equals 36. So there are 36 terms. And so here the sum is going to be 125 times 36 over 2. So then I multiply that out and get 2,250. So in addition to, it's a good wrap-up color. So in addition to the formula from yesterday, the definition of an arithmetic sequence, the nth term is the first term plus the constant difference times n minus 1. And now what we have is the sum is going to be the first term plus the nth term, whatever the nth term is, times n divided by 2.